Okay, my wonderful friends. This is just too much. Every day it's more and more of too muchness. How much can you take? What are we looking at here? Well, it looks like a bunch of a wall of rocks. Well, what is this ball doing here? That ball doing there? Why is this color here versus this color versus this? Why is this a different texture than that? What the hell is going on? Well, as you know, I study mud fossils. I deeply study them. This is a friend of mine, Tyson Carlson. He's out on the West Coast in Oregon. He's out collecting information on biology. This is not just a wall of stone. This at one time was biology, and I now fully understand all of the layers, literally all of them now. This is what they call interstitium. This has just been discovered. I've seen this for 10 years, 12 years, and wondering, what the hell is this? Why is this separated from... Because these are in mud fossils. You see that little line right there? You see this line? And then you see this color line right under here? And above it, there's actually this little tiny black line. Every one of these, where you see a difference in color or texture, is a different type of tissue. Some of them are connective tissue, some of them are muscles that pull in and out, some of them are fluid layers, some of them are veins and arteries, some of them are interstitium, the stretchy, pulley, rubbery stuff. Now I'm going to explain to you every bit of this. Now before I get into this, additionally to talking about stone and mud fossils and all this stuff, I'm going to relate this to our biology in our body, because this layer right here, I'm going to show you in the, like I said, they just discovered this. So they have no clue what it is even about. I'm going to tell you this layer right here is your immune system. I'm not kidding you. That's where all your enzymes exist. Like I say, when I do research, I do deep research, and I can show you this quite factually. This doesn't mean I am giving you any medical advice. I was struck twice by YouTube for giving medical advice, and all I was talking about was how viruses work and how they attack collagens, which I'm going to show you that again. Now, I'm on a little bit of shaky ground here, but I'm not telling anybody to do anything. This is just as much for researchers and doctors as it is for the average person, just for their, just general interest, because they're not going to be able to do anything with this. I'm just going to tell them these are actually, well, you know what? Go call from, I think it's UC Berkeley or something like that, did a video that says your textbooks are wrong. This is not where your tissue is. Watch. Okay, what you are going to be looking at in a second is a new organ system found in the human body just in 2018. It's this stuff here. And it's everywhere. It's everywhere in your whole body. And what it is, it's called interstitium. And this is a flexible fabric that can stretch and pull. And these little black balls are the anchors that let this all come back to where it should be. So you can stretch around and your organs can do this and that, but they'll always come back. Your lungs, such as this one right here, are completely covered with that interstitium, and this is very, very flexible because your lungs. Your bones are covered with that interstitium. It's membrane, but it's very thin because it's a bone. It doesn't have to do this all day long. But your veins, your arteries, your lungs, your heart, all those things have to have extremely stretchy fabric, rubbery collagen as their interstitium. So there is different areas of interstitium, fascia, whatever you want to call it, that are specific to that area in your body. If it has to be real rubbery, well, you're in a lung area, that type of collagen. And there's 28 different types of collagen. Some of them are very springy. You see these brown little things? I'm going to show you this in detail in a second. Let's just do that. But that is what we're going to be talking about. And I'm going to be showing you this in the mud fossils. It's everywhere. And even the tissue, you see, they say skin. Skin is the same thing. This is nothing more than interstitium. All of these different things are skin, all the coatings of all your organs, and all those organs are different coatings because they're of different chemical constituents. Some of your salt is in one area, your kidneys, let's say. Stomach has acids, which obviously you can't have the same coating. You understand, it's different chemistry. And even the feathers of a goose are made from collagen. Because this is what this is all collagen, 100%. And feldspar, which is the coating of every bit of this, every single fascia, and every single collagen turns to feldspar. You see it? That's all feldspar. This is all feldspar. And every one of them has some affinity to bond with aluminum aluminum silicates. The aluminum silicates actually create a coating that wraps the bloody stuff. You see, that's where his throat is. And that turned, and that's where his artery is, right there. And he died laying from a flood, flat on this side, and perfect on this side. Feathers and everything were good. This all turned to basalt, because it's a different chemistry than the feldspar, which is the collagens. And the same thing with this. This still has a ton of blood down at the bottom here, which it's loaded with blood anyway inside, saturated, basically. So what we're going to look at is the mud fossils that show all this stuff. But I don't need that special equipment, which, you can get an hour playing around with it and this and that. No, you can do this all day long. Anybody can. You can walk in as long as you go by the ocean, you should be able to see these things eroding away. They're all over the world. Okay, don't forget, this stuff is everywhere on your body. It's a new organ system that covers literally everywhere, and it's in every one of your membranes. It separates membranes. And I'm going to tell you, you have no idea how many layers there are in the human body of membranes, and I'm going to show you. I can prove it. I don't know about the human body that I'm going to be showing you. It's a gigantic creature, but we'll be able to see literally thousands of membranes. Okay, my friends, this is just so far over the top, it's amazing. This is my friend Tyson Carlson's hand. No, he's got mud fossil adventures. And he is on the coast of Oregon, west coast of the United States. And it's 100% biology. And basically, as far as I could determine, every coastline is. Some of it is very, very densely covered with sand, but that's not the case here. Now, what I want to show you is, look down here. You see all those little tiny little layers? Those are membrane layers. And I'm telling you, there is so many layers in a creature's body, it's just beyond belief. And this creature is just literally miles and miles and miles long. What it was, I don't know. More than likely some form of a reptile. Now, this could be actually ribs. Watch this. This is Tyson.
It looks like it's just oxidized.
You see how they're coming out like this, and they're like a chunk here and a chunk here and a chunk here, and that could be bone. You see it?
I think that's all that is.
Look at the layers. Now, think of this. The layers in here, it would take the best microscope in the entire world to be able to see those layers. You'd never see them, I don't think, ever, with anything. In here, this thing is 6, 7, 8 feet thick, where we would be able to hold us up that piece of tissue and look right through it. And there's that many layers that you'd never, ever see. I don't care what you had for a microscope. Think of the size of this thing, and think of the number of layers you are seeing. Because that's what I was finding in these mud fossils. I'm thinking, whoa, this is crazy. Now watch.
But this is layers of this creature.
Boy, you ain't lying, Tyson. Look at these layers. Look at these layers. Look at these layers. No.
This is not cross bedding from sand.
No. All right, now, every one of these layers, in between each one of these layers, is some kind of a membranous tissue. These are, a lot of this is connective tissue. Connective tissue means something that's strong and structural. Then you have to have stuff that's gooey, that moves things. Then you have to have blood supplies. Then you have to have anchors so everything can come back where it was. There's a lot to this. Anyway, here goes. This is the interstitium. This here, I believe, was like a veinish area. Oh, I'm sorry, this one here. That's black blood. This up here, see the balls? Those are the interstitium balls. I'm going to show you this in a second. And this layer was interstitium. Now, this layer right here, this exact red layer, I believe is the layer, is what is your immune system as far as I'm concerned. And that red layer carries the enzymes. This below is where it pulls back and forth and attaches. Now, this creature is beyond belief gigantic, which they all are. People have no clue. You know, look at the size of this thing. This is an uplift of some form of its body. This is all body tissue running through here. Absolutely incredible size. But again, I say that, but it's not incredible. It's everywhere. They're everywhere the same gigantic sizes. People just always thought they were rocks. That's not a rock. That's biology. All of this stuff is layers of tissue. All right, I've been doing a study on what was written in history about giants. And this is from, it's called Concerning Giants, Volume A, Issue 193. This is from December 7th, 1872. And these are the things that were written. There were giants in the earth in those days and so forth. Now, it comes down to here. I think I had something highlighted down below here. Let me find it. Hold on a second. Listen to this. This is King Og. These are things that were written, and nobody ever considered them to be even possibly true. The Eastern nations have many extravagant traditions concerning this giant, according to some of the Arabian historians. King Og excelled by far all other monsters that ever existed. He was so tall he could reach the heavens. He had an unaccountable hatred of Noah, whom he continually sought to kill, but Noah proved too shrewd for him. Whenever the giant pressed him closely, he withdrew into the caves of the mountains. Og could not follow him. Og was just too big. One day, in his rage at his numerous discomfitures, the giant plucked out his beard and threw it at his nimble enemy. He plucked out his beard. The hair at once became a cedar tree, forming an immense forest that covered the whole plain, and from which Noah eventually cut the timber for the ark. Og survived the deluge by wading the waters, reaching no higher than his knees. The only inconvenience he experienced during the flood was that he was reduced to a fish diet, his sole food, during its continuance consisting of whales, which he roasted on the disk of the sun. There were stories that apparently it must have been him. He was so tall that he could hold up fish towards the sun and cook them. And I'm thinking to myself, the sun is way too far for this guy. No, I don't care how tall he was. Well, I don't know now. But really, all he's got to do is reach the ionosphere. The ionosphere is 2,700 degrees, and that's not that far out for these gigantic creatures. So it says, this is no more ridiculous than the stories told by the rabbins of Adam. Now listen to this, this is Adam. I never knew any of this stuff. Now, if these were stories told, that's what they're saying. So these are stories told by rabbins of Adam, whom they say God first created of a height so prodigious his head reached the heavens. Now this is Adam. But the angels were terrified at the sight. God reduced him to 1,000 feet high, or according to others, 100. The later estimate, however, is undoubtedly much too small, and I agree, for the father of the human race, when driven out of paradise, waded through the ocean which separated this world from Eden. He waded through the ocean. Goliath and the Philistine of Gath is supported to have been another representative of the Rephaim, a remnant of that race having taken refuge with the Philistines after their overthrow. I mean, this goes on and on and on about the giants in Gath and all these places. And my giants that I have in my own yard, my own property, I have one, its fingertip is 3 feet long. And it's a DNA tested in the whole 9 yards. And there's no question it's anatomically exact, including fingerprints and the fingernail. So deal with that. All of these things are written about in history. I never realized it. There's so much. And so I'm going to be going through this a lot. But they're talking about Adam being so tall, and he reduced them down to 1,000 feet. And that's not, that is small, actually. That's tiny, 1,000 feet. That wouldn't even reach up to the knee of a lot of them that I have found on, on Google Earth, including the Devil's Tower. That's a foot. And the other foot is either deep in the, I believe it was sunk deep in. Because one foot is going to normally push into the mud, trying to lift the other one out. And I believe that's what happened. And the one, because I could see sort of an outline of the other one deep in there. And I believe it was drilled down into, you'd find that it was made primarily of the same stuff that the other ones are made of. All right, you want to see something cool? This is Devil's Tower. These are literally the tendon fibers. In us, you need an extremely powerful microscope to see these. You see these all ripply looking things here? And they're like scale looking stuff. You know what that is? That's called Slurpee. Well, what is Slurpee, Roger? Well, Slurpee means small, leucine-rich proteins. And what are they are? What are they? Or what they are? I've heard it both ways. They are the slime that makes your tendons slippery. Well, guess what? How slippery are your tendons? Well, guess here's how slippery they are. Incredibly slippery. Now, what are we talking about? Synovial fluids. Well, what are synovial fluids? They're the Slurpees. Now, here's the coefficients of friction. One of the most slippery thing there is ice on ice. I'm sorry, not ice on ice. It's Teflon on Teflon. But then you go into synovial joints in humans. That's where you have your fluids. Look at this now. You got two ways to look at them. When they're just laying there, how slippery they are, and if you're pulling something along, how slippery are they? Well, usually, they don't get any slipperier. But watch this. Synovial joints in human, 0.01 is 4 times slipperier than Teflon on Teflon. And then when you start to pull at it a little bit, it becomes slurp. That's when the fluid-filled bags begin to squish and pull and pull and squish. That's how you get this extremely low coefficient of friction as you're pulling it. Now, I work with, anatomists and so forth, PhDs. They don't want to be spoken about because I'm kind of an oddball, but they agree basically everything I said. I've never had one of them say I'm wrong. Absolutely none. This is the Slurpee. Your tendons have to slide like this. Now, one of them told me, he does autopsies all the time. He says when he can find somebody that this stuff here is like gooey, he can sort of just goo it around. He says that guy is very flexible and mobile. He says some of them, in their back and so forth, where you have a lot of this kind of tendinous material leading to muscles. That's what makes it painful, is the tendinous materials. And he says some of them, he can't even move it. He has to use a scalpel to cut down that tendinous material. You see that? Now that's a foot. And I'm going to show you where it breaks at the in the human body. Hold on a second. All right, this gives you an idea what I'm talking about. There's going to be fascia coating all of these tendons. There's goo over the top. This is showing the muscles and the tendon attachments. But there's going to be that fascia over the top, just like there is over the slurpees of the ankle, which is Devil's Tower. Now, it didn't break way up here. They break down in here. And it's called an abrupt transition, and that's where they break, is about here. And they break flat as a pancake, because these things are stacked in little chunks. That's what gives them the ability to flex, almost like cells. But this is the part they talk about. If you can move this gooey stuff, the guy's fine. If not, you got trouble. And the slurpees are all over every one of these tendons, and there's a zillion of them in there. Like they're all over your body. They're everywhere. Now, what you want to think about here is this is literally the wrinkle zone. When they snap, they wrinkle. Let me show you. You see that? That's what happens when you cut a tendon. They're under tension. You end up with this very wrinkly zone up at the top here, and then they come back to their normal looking tendon. Now, where you see these colors and these mosses and things growing, that's where there was some red blood. There was red blood here, and it looks like there was another something feeding it here and there, vein and artery, whatever. Now, this is, as I showed you before, that's exactly the structure of the ankle. And this is where it breaks off, right there, just as flat as a pancake. And where all these are growing here. They're growing there because there was red blood vessels there. They're growing in the blood, same as they are here. They're coming up here to service the tissues. And now these plants have found that red blood to grow into. Plants love red blood. They're not growing out of here. Right? There's a lot of places they're not growing out of. Why aren't they growing out of here? These are where the service blood vessels broke off, basically. All right, this is a little different angle. This is the calcaneus at the back, and the tendon runs right up and attaches to the muscle, as I showed you before. All of this red stuff, that's all muscle runoff. Now, there's some circular patterns here and there. It had another foot. Now, whether this is part of it, you look for the circular patterns. Now, it might be here, it might be over there, I don't know. Usually, when you see one, and normally that's what I see, is one, and then I think one is pushed deep into the mud probably to try to pull this one up out of the mud. I don't know. All I can say is that was a foot, and this was a slurpee, and this is the tendon fibers, and that is exactly what you would expect to see if it broke right off there. The abrupt transition. I can find the blood. The whole thing is there. Somebody put a picture of baby sweet corn roots underneath the Devil's Tower and said, "Oh, we just discovered these roots." Now, here's a little perspective for you. Look at this. A Statue of Liberty is this tall. This is the Statue of Unity in India, 182 meters. All right. Devil's Tower is twice as tall as this. You see? It's the size of it. There's the wrinkle zone, and there's all the tendons, and here's all the things that are growing in something that is edible, which is blood vessels. All right, just so you understand, this is the wrinkle zone right there, exactly. It breaks way down here, not way up there next to the muscle. And it's because this is the weak spot. There's a weak spot right above the tendon ball, which goes in. We're at right about here at the ground. All right? Remember, it has a little lumps that go over. So that thing is in the ground up to about there. Now the other foot, I believe, must be in the ground deeper, and the red blood and all that stuff is piled over the top. But you can see some areas that are round. Are they from a foot? I don't know. It had to have 2 feet, maybe. I don't know. Maybe it only had 1 foot. Now this is Tyson Carlson's channel, Mud Fossil Adventures. Tyson's Mud Fossil Adventures. Now, these, to me, almost look like ribs, and could be from a snake. Listen to this now. I'm just gonna play it for a second here. He's coming. Look. Look at the size of this creature. This thing is going all the way out, and these are part of its body. All of this is part of its body. I know it sounds just incredible, but it is incredible. What can I say?
I want to get up and over that.
Look, all of this goes down all the way up over. Where it ends, I have no idea. How long it is, no clue.
That's why I'm down here today, too.
Look at this. This is all tissue. This is all tissue. Look at this. You see how many layers of tissue there is?
There. See this? Look. Something's going on.
I think that's the center of a rib, or a segment of a snake's ribbish thing.
That uses for servicing for blood. Something's going on.
I believe. Yeah. See, look. Yeah, he's right.
Those are deteriorated off.
But you see how they're sticking out of here? I believe these are snake ribs. Let me just show you something. And I think that's what these are. Before I do that, I want you to really focus in here on how many layers of tissue there are. And how many layers of tissue there are up here. You look at this, that's not just one big layer. There's thousands of layers in this one layer right here. There's so many layers that nobody could ever count them ever. Now, these, I believe, as Tyson was just showing you, we had the center thing. I believe these are the rib bones. Now, they have a very weak spot just after they emerge from the backbone on reptiles. Let me show you. But this is unbelievable, the number of layers. Look at that. I hope you can see the number of layers there. It's just phenomenal. He's got a really, really good spot. And he's a hard worker. He goes out, he does it all a lot. So it's Tyson's Mud Fossil Adventures. Now, let me show you the snake and its skeleton. Okay, here's what I want you to focus in on. That little bump right there is what I'm saying Tyson's looking at. These are just going away. Those are really cheap. I talk about structural things that are strong, and then I say the cheap stuff. Well, you got really cheap stuff as your, gooey stuff. That when I say cheap, it's not necessarily cheap. It's just that it's mobile. Let's go with that. So your guts and all that business is pretty mobile in the beginning. Once it hardens up, it's done. But this is different. And these also are the flat irons, I believe. The tips of those little, if you can see that. This thing gets flaky when you get too close. Yep, see, there it goes. Flaked out. See? I believe that is what we're seeing in flat irons. And we're also seeing that at Tyson's place. Now, what does that mean? From there up, there's all kinds of flesh, and that makes it so they can move all these little things so they can slither around. And then there's also, it's going to wrap around here with tissue that gives it that slithery ability. Alright, I'm going to tell you something right now. I also believe this is from a reptile that has the same skeletal components. Now, this is just eroding. They could take a hammer and put it in, and it just falls apart. This stuff here is, I forget what it is. It's a extreme absorbent, bentonite clay. It's bentonite clay. Now, I believe this is still a remnant of the actual bones. And if you went deeper into here, I believe right about here is where the stuff that Tyson has, which is the end. I watched this guy, this a guy named Myron something. Anyway, this is what I see. These are called flat irons. And I think they're in Colorado or somewhere out there, Arizona. Now, there's a lot of them out there apparently. And I think they're just nothing more than the serpent things. And I believe right about there is where the stuff that Tyson has. I'd love to see the chemistry of this just before, because I believe this is where it's broken off and it's still eroding a little bit at the edge. Tyson's are completely gone down to that bonish looking thing. Let's take a look at Tyson's, and maybe we could collect some samples. We know what these samples are. They're bentonite clay. Now, I'd love to see what that is down there. Is that still bentonite? I don't think so. All right, this is one that I watched a couple weeks ago, or a week or so ago, about the flat irons. It's called Myron Cook, and he's discovering the origin of this beautiful rock formation. I say that's a skeleton of some sort. It's too regular. Now, look at this. You see this? This is actually flattens right out there. Now, is it just because there's a hill here? I don't think so. I think these are the tips, just like Tyson has almost. And they still have, or maybe even Tyson's has the same stuff, this bentonite. Now, this is in a different geological condition. He's in the ocean next to salt waters and so forth. This is just in the middle of nowhere land. It looks like to me desert. So let's go take a look at Tyson's again. Now, what I want you to look at is you see all these skeleton parts, I believe. Now, what happened here? We got a different situation. This could be his head or something. Why is that stripe way, way up like that? This is a different bone structure from here up, which could be something that does this, or I don't know what. But they're big and they get smaller. Watch. Look at this. This is the best shot I think I'm going to be able to give you. All the way down. There's a zillion of them. That's got to be a bone structure as far as I'm concerned. That's what it is. Now, and again, this does something different. Now, you see that? That's not like this. This has this bentonite clay in it. They can just dig like that and it erodes right out of there. Now, is that erosion in a condition of being where it is, or is it I don't know. But Tyson is next to the ocean. Very, very much different chemistry there. But this intrigues me. I'd like to know what that is. I can tell you what it is. In my mind, it's some kind of a fleshy investment for that bone. All right, here's Myron again. Look at this. I believe that's what Tyson has where he is. You see there's a separation down here? These just are these little bony things which have eroded into a clay. And I think that might be because of the conditions they're in. This looks to me like it's sort of a muscle wrapping. You see how it goes this way and that way? That's how muscles wrap. I have them all over the place. Anybody who understands muscles understands that's what a muscle wrap looks like. All right, I'm going to let Myron continue on here. He says he jumped up over here. And you see this? That's all the same sort of stuff Tyson has. Everything goes in the same direction because the body goes in that direction. Look at all the way down there a little bit. These things are absolutely enormous. And these are sticking up here. Now, how it died, I don't know. I don't know. I have no idea. But these look like they were coming out. But I just don't know. Let's take a look and see what he shows.
Here on the other side of the valley, kind of up the ridges, you can see them behind me, to show you this principle of what we would expect for hard stuff, for hard things. That's what stands up on a ridge. This is a miniature version, not very big. That's what stands out. The soft shale that was on top of this, I can look down here, it's stripped back. It just,
All right, so basically what he's talking about is the skin. All right, this is some kind of structural component that held it together. Because that's what connective tissue is. It's tougher than the muddy clays.
just strips right clean back.
Yeah, that's the muddy clays. That's what allowed
So I
them to.
want to show you
Look
how
at the
shale
size of
normally
these.
erodes. See, I'm standing on soft shale right here. This is soft shale. It's a dirt.
No, it's mud. It's for the runoff of a creature's body. It turns into mud, basically. I've shown this very, very clearly, especially in the interstitium stuff. But I think this is the ribs of a gigantic snake. Okay, I'm going to leave it at this now. What I'd like to see Tyson do, I want to talk to him, see if we get him to get some of this stuff here. I think this is going to be almost like that bentonite clay. Now, in that valley he was in, it's not being eroded like it is here by the ocean. His were still coming out, and then they just broke right off at that snapper spot. Now, this appears to have still got some.
Bud,
Watch, no, watch.
something's going on. I believe.
Look, see, same thing here.
Yeah, see?
There it is, the same thing. Now, each one of these, I think, is one of these.
Yeah, he's right.
Each one of these is a rib. See them?
But you see how they're sticking out of here? I believe these are
Yeah, I believe these are that heavy-duty spot where these little flexible ribs can twist all kinds of ways, and then they have to have some very solid structural things to move back and forth a lot, because they're snaking all over. That's what they did, snakes. All right, so maybe we can get Professor Meyer in there involved in this to see, does this material match the material he's got? Is it similar? It looks to me like it's quite porous. I don't know if it is or not, but Tyson can surely go up there with a pick and pull some of this out. He's got to get inside where the salt has not really altered the molecules. Salt is very, very aggressive. Now look at this though. Look it up here. Look at the layering. There is so many layers that nobody has ever considered. But I can see them in the mud fossils just like Tyson can here.